So let's summarize our plan for finding particular solutions to a second-order linear differential equation. This technique is called variation of parameters because we're finding these, we're letting the parameters in our particular solution vary instead of being constants. So the idea is if we have a differential equation that looks like this, so first of all, you might need to rearrange your differential equation so it actually looks like this. In particular, if you have a coefficient function out in front of your second derivative, you'll need to divide everything by that coefficient function to clear that coefficient. But once you have your equation set up like this, then you can find a fundamental set for the associated homogeneous equation. That'll give you y1 and y2. Calculate the Wronskian. If this y1 and y2 is a fundamental set, then this Wronskian is guaranteed to come out to be non-zero. And so that means when you then use these formulas to find u1 prime and u2 prime, it's actually okay to divide by w because w isn't zero. So once you have the Wronskian, you can use these formulas. Now we did a bunch of guesswork and algebra to come up with these formulas, but now that we have these formulas, we're just going to use them. So right, that's the advantage of working something like this out in the general case. You get a formula that you can use without having to redo the calculation every time. Okay, once we know u1 prime and u2 prime, of course, we can integrate them both to find u1 and u2. And once we know u1 and u2, we can form our particular solution just by taking u1 times y1 plus u2 times y2. Now, when you do the integrals to get u1 and u2, you might end up with some constants of integration. But remember, we're just looking for examples of u1 and u2. We don't need to write down every possibility for u1 and u2. So if you can pick values for those constants of integration that make this particular solution nicer, feel free to choose those constants.